Hello everyone, thank you for coming. My name is Patrycja Wegrzynowicz, and today I'm going to tell you about how to develop Java applications in a secure way. Briefly about myself, I've got over 15 years of professional experience, all the time as a working and coding developer. And I must admit that I still love it. I've been working on projects ranging from bank systems, domain name systems, so pretty much mission-critical systems. And later on, I've moved to the other side, like I've been working on how to detect software bugs and vulnerabilities in software. So more recently, I'm working at Unita. It's a startup with the idea to bridge the gap between the industry and the academia. So basically, we are working on an automated tool for detection and refactoring for various anti-patterns and vulnerabilities in software. Regarding performance, databases, and most importantly, security. You can follow me on Twitter at YonLabs. That's important because during today's session, I'm gonna tweet some information which might be helpful for you for your exercises. Okay. So what about today's session? First of all, a very short introduction to security to be on the same page. Then we move to OWASP, that's Open Web Application Security Project. And I'm going to tell you a little bit about top 10 security risks according to OWASP. Then we move to security in Java EE. I will show you several attacks and how to harden your application and make it less vulnerable to various security vulnerabilities and attacks according to OWASP. And we end up with some security takeaway for you for the future. Okay, 2014. It's been so far pretty scary year in terms of security. Heartbleed. How many of you heard about Heartbleed? Yeah, everyone. So OpenSSL is got that buffer overrun bug, which exposed nearly most servers based on OpenSSL. Then most recently, shell shock back in Bash. Have you ever heard about that? That's a pretty new thing. Yeah, pretty popular. And so when it comes to other security breaches, that was quite a very serious, quite a few security breaches in 2014. Like, for example, eBay or other resellers, which lost some confidential data of their customers. And as far as I remember, over 100,000 customers of eBay were supposed to change their passwords. So that's pretty serious. In another online shop, it was the case where over 2 million credit card numbers were disclosed. So that might be pretty damaging for brand, right? So basically, every system has bugs, security bugs. There is no system which is 100% security proof. there are only bugs which are discovered, and the ones which are not discovered yet. Right? So security vulnerability is sort of a weakness in a system. This weakness might be exploited by a hacker. In terms of OWASP, hacker is often called threat agent. And the threat is a possible damage which is caused by exploiting vulnerability. Those attacks might have very serious impact on business, right? From the technical point of view as well as from the business point of view. Technical impact factors include loss of confidentiality. So, for example, the data of your clients are exposed, loss of integrity. So the data are modified or deleted or in another way destroyed. Loss of availability. So, for example, your system becomes unusable. So it stops serving the clients. As well as a loss of accountability. So we can't identify the right person responsible for the damage. And there are serious business impact factors which can be very damaging to a company, like financial damage, like reputation damage, like non-compliance to your regulation, like privacy violation. So these are pretty important from the business point of view. Okay, so in terms of security, there is always a gap between developers and security officers. So usually we are not on the same page. We talk different vocabularies. We focus on different things. From the point of view of developers, it's about good code quality and how to meet deadlines and how to meet requirements, right? So security is not our priority usually. That's a completely different point of view from the security teams. They focus on security, but they talk in different terms, different vocabularies. They talk about session IDs and IPs and network traffic usually, and we can't convert their opinions to what we want to change in our application to make it secure, right? We don't understand how to fix some problems. And that's the gap. And Open Web Application Security Project, it's a non-for-profit organization with the goal to increase security awareness among IT professionals, including developers. So they produce very useful documentations, including top 10 security vulnerabilities lists, including guidelines also for developers, how to deal with those vulnerabilities. A lot of cheat sheets, a lot of information on Wiki how to deal with security vulnerabilities. But they do not focus strictly on documentation. They also focus on working tools and examples. So one of the project is Z-Attack Proxy, which I will show you today, how to use it to test your application and see some vulnerabilities and exploit some vulnerabilities. They've also developed Enterprise Security API, which might be useful for us developers because it contains a lot of functions for encoding and escaping, basically input and output validation and sanitization. Also, one of the most prominent projects from my point of view is WebGoat, which is a sort of educational application for IT professionals to make them familiar with exploiting security vulnerabilities. So that's definitely something you should be aware of, and you can get familiar with those projects and tools later on. So let's move to top 10 security risk according to OWASP. The last list was made in 2013. And it's based on some sort of statistics from many companies. And we see what vulnerabilities are the most popular and the most risky for companies. So the first place is injection. Injection. How many of you heard about SQL injection? Everyone, right? So SQL injection is the most popular kind of injection, but not only SQL injection. There is command injection, like in that bash bug, that's command injection. We can have like XPath injection. So there are many others types of injection. The second place goes to broken authentication and session management. Basically, that's a huge problem, also in Java application. During this tutorial, I will focus on session management quite a lot, because usually other attacks aim at stealing session. When you steal session ID, you can hijack session for a user, and basically you can impersonate an authenticated user. So that's a very important how to program and manage sessions in Java environment securely. The next one is cross-site scripting. It's basically it's also a type of injection, right? Because we inject HTML code into a browser. HTML including any scripting which can come with HTML, right? So XSS is kind of injection, but because of its popularity and because of its other target, because it doesn't aim at servers, it aims at browsers, client side, it's been like on a separate position in the list. In secure direct object reference, it's about when we expose underlying identifiers, so like database identifiers in our web pages, and then hacker can manipulate them and possibly get access to some assets which are not supposed to be disclosed to him. Security misconfiguration is about all types of misconfiguration only. Usually when it comes to descriptors, when it comes to application servers, think about all those admin consoles which come with default passwords, not secured at all, etc. Once I deployed Tomcat on some public server, after like 1 hour I noticed I didn't secure it at all. It was like default installation. So after like 1 hour or so, I noticed that some kind of a robot deployed new application to my Tomcat with aim to execute, with system execute basically, inside the servlet. So basically, the hacker could get access to that public server on the level with privileges of the user under which the Tomcat instance was running, right? So those kind of configuration we as developers, we usually do not pay attention to, right? Because for us, development should be fun, and configuration is not fun. So it goes to DevOps. Sensitive data exposures. We need to take care not to lock password. We need to take care not to lock credit cards. Basically, when we deal with any sensitive data, we need to think how to protect them, how to keep them secret from the outside world. Missing function level access control. It happens pretty often that in the course of the development we change the authorization all the time, right? That's we add new functions, new functionality, and we forget somehow to put security check whether or not, for example, this function is dedicated only for administrators, right? So it happens. We are only people. Nobody's perfect. And that's on the place number 7 in our list. And then it goes cross-site request forgery. That's another kind of attack on session, because it's not about stealing session, it's about using session. So hackers craft special requests to and trick victims to go on the web page and click link, and instead that link sends a request to a different server with privileges, session ID, cookie of that victim, right? It exploits the default behavior of a browser. A browser automatically sends cookies with every request to the domain for which the cookie with the domain for which the browser has cookies for. Okay, and almost the last one, using known using components with known vulnerabilities. As I said before, nobody's perfect, and today's modern development with Java, it's about huge technology stack, right? We use a lot of third-party libraries. we run our application on application servers in web containers. We use different databases. And all those components have their own vulnerabilities. And we need to take care of that as well. But it's more about configuration than actual development. And unvalidated redirect and forwards, it's again attack to trick a user to go to some sort of a malicious web page. If we don't validate user input, that's a problem. And a potential weakness which further on might be exploited by a hacker. Okay, so during our talk we will focus on session management, broken authentication and session management. We'll focus on cross-site scripting and cross-site request forgery. And then injection, that's our priorities. We'll also tackle a little bit other things, and we do not tackle at all security misconfiguration and using components with known vulnerabilities, because it's kind of out of scope of development, or at least not on the primary track. So I will take a look at this list from another point of view. I'm more interested what bad could happen to an application from different kinds of attacks. So the first group is going to be session attacks. So attempts to hijack session. Then we'll talk about client-side attacks like cross-site scripting, cross-site request forgery, which are aimed at users and their browsers. Then we'll talk about unauthorized access attacks, which basically exploit missing level function access control. And then server-side attacks, which basically the primary form is injection. Okay, let's start. What's HTTP? HTTP is a protocol to transfer content over the internet. The important thing is that HTTP is stateless. So at a typical situation, we cannot identify from which user given request comes. And that's a problem for us developers, because usually we want to identify the user, to assign him or her some privileges and functions and data and so on. So for us developers, it's important to have sort of a session. Session is a way to identify interactions with one user. And how is session implemented? Any ideas? Basically, we need some sort of a unique identifier associated with every request which comes from a given user, right? So if you are a Java developer, you know about JSession ID. That's in Java world, that's the way to identify a user. That's the way to keep a session. But there are also other ways, like special header in HTTP requests. JSession ID might come as a parameter or as a cookie. Also, sometimes people think about hidden fields, but that's not very useful, as hidden fields are only applicable for post HTTP requests. Session hijacking. How can we get access to other session, to other users' session? We can steal his or her cookie, and this cookie might be visible, ID, not a cookie, because it might be a parameter in URL. Think about URL rewriting in Java and JSession ID in URL. We might be sniffing network traffic and see what comes in requests and see JSession ID in requests. We can take a look at server logs. Sometimes people log JSession ID just to identify one session and one interactions with one user, just to debug, to simplify debugging later. We can also steal session by XSS, cross-site scripting. Another type of attack on session is session fixation and session prediction. Session fixation is that a hacker provides a victim a special crafted URL or a browser which has already open session. And then user comes and logs in without changing session, right? That's session fixation. Session prediction. In some technologies, session IDs might be guessable, predictable. It depends on technology used. How many of you use Jetty server? Jetty. A few of you. So probably you noticed that Jetty has pretty short session ID, JSession ID. It's like only 8 characters in length or something. So it's pretty short. For session ID to be of a good length is at least 16 characters. So if it's, for example, not a very random session IDs, sequence IDs, it might be easy to predict based on the previous session IDs, and the hacker might get access to other people's session. Okay, so now you will hijack my session. I will log into a sample application. Then I will post a link with my session ID via Twitter, and then you will access it. And we'll see how many people access the link and from what IPs and what browsers. So you'll see that's pretty easy to okay, I will try to. We'll see whether or not my session expired. Yes, it's expired, so I will log in. You can try it out. After you hijack my session, you can steal my secrets. Okay, so you will see that JSession ID is visible in URL. I guess that you are not that are not able to type so fast, so it's better for you when I post it. Okay, so it's enough for you to access that link. If you access it, you should get such a web page as you see with "Hello, Patrycja," even though you are not Patrycja, I guess, none of you. And oops, that happens too often during demo. Okay, so I will post it once again. And I can show you that even though I'm in Firefox now, I can log in with the same session from Chrome. When I don't include session ID, it's like a new session, and the server requires a new login. Okay, it seems that nobody clicked the link. Who managed to click the link? Oh, I see. Windows NT, the same address. I guess that we all use Oracle Wi-Fi. That's why all our devices are visible under the same IP address. Anyone else?
I'm not on the Wi-Fi. One of those is mine, but I'm not on Wi-Fi.
You are not on Wi-Fi, but it's...
Yeah, we see 25 hacks on his screen.
Oh, probably I...
It doesn't show me.
Oh. Oh, it was on the previous session. Okay, I can click the link of the previous session. Oh, yeah, 30 hackers, quite a lot with different IP addresses. So you see, that was so easy, right? To hijack session. It's enough to get our hands on a cookie or JSession ID. So how to prevent such situations? First of all, we should avoid session ID in URL, right? It's too easy to hijack such session. In the sample application, I forced usage of URL rewriting. But if you don't configure anything, the default is cookie, but URL rewriting is possible as well. For all those users who disabled cookies in their browsers, or all those users who use browsers without cookie support. It's minority at the moment, but still. So by default, yes, you can have URL in JSession ID in your URL. So you should disable URL rewriting in your app server, and that configuration is app server specific. Or you should use web.xml and tracking mode, which is available from Java EE 6. So you should configure your web.xml to tracking mode cookie. No URL rewriting at all. You can see the configuration in my application. It was tracking mode URL just to force URL rewriting and disable cookies at all. Okay. Cookies are better, but are they enough? What do you think, guys? Absolutely not. Because without any encryption, you can do session sniffing. Network monitoring and packet sniffing, and you can get your users' session cookies in clear texts. And then once a hacker got his hands on a cookie, he can make use of it. It's not that easy as it was in JSession ID in URL, so I can't post a link or anything. But you can imagine you are a developer, right? So you can write your own code. It's not a rocket science to do a HTTP connection and set up some headers and cookie and connect to the server. But that's a hard way. There are many of easier ways, like browsers, plugins, and add-ons, or intercepting proxy, like OWASP proxy. You can just configure proxy in your browser and then change requests when they go or sent to a server. I was supposed to do a demo with session sniffing, but I guess that we can skip it. That's pretty simple. The tools I use are Wireshark and Z application proxy. Wireshark is for packet sniffing, so I just can see all the packets with the content, and then I use intercepting proxy to set up a cookie. So basically the problem here is that we do not encrypt our session cookie identifiers during transport. How to avoid session exposure during transport? Use HTTPS, right? And with session cookie, we can configure a web.xml to send cookies only on the secure channels. Also, there is another security constraint which can be set up in web.xml for transport to be confidential or for the transfer to provide confidentiality or integrity. Basically, in Java application, it means in both cases the same. Use HTTPS. So there are 3 places where session can be exposed. During the transport, that's pretty obvious, so we should avoid an encrypted transport. The session can be seen in clear text on the client side, and that includes such attacks like XSS, cross-site scripting to grab session cookies, or other kind of attacks on browsers or operating systems. All those malware and viruses often steal cookies. And the third place is server side. We should not log our session IDs in any log files. We need to think about session replication, secure session replication in application clusters. When we use clusters with session replication, we need to take care of that replication is done on the secure channel. And there are various attacks on servers, like a hacker can do memory dump just to read session IDs in clear form. Think about session ID as your sensitive data, right? So it's connected to another security risk from OWASP list, sensitive data exposure. So for all sensitive data, including cookies, including passwords, including credit card numbers, including social security numbers, and so on. Encrypt at rest and in transit. Use strong algorithms and long keys. Remember to disable autocomplete and disable caching on web pages, which are used to gather all those sensitive data. So how to steal a session if secure transport is used? We can attack the client, as I mentioned before. And now we do a demo. Previously, you hijacked my session. Now I will hijack one of your sessions. We'll see who will be the lucky victim. Basically, we need, first of all, we need JavaScript code to steal a cookie. I've prepared a servlet which logs down stolen cookies. And I've prepared a vulnerable application to be exploited via injected JavaScript code. So it's kind of XSS attack. I will store that malicious JavaScript code in the app. I would like you to log into a vulnerable application. I will post a link in a moment. There is very basic authentication. Any non-empty username is accepted. And after I will store malicious JavaScript code in the app, you would be able to click View Others opinion page, and then we'll see how many sessions I will be able to grab. Okay, so that's that's for you guys. And now it's my turn. Here you see a text area when a user can share his or her opinion about the service. So I will share the opinion together with malicious script. I've got that script prepared. So let me get it. So you see that that basically it's access document cookie and then requests to load an image. Basically, such construct is used to avoid to bypass same origin policy in browsers, because you can't request HTTP GET to other pages from other other domains. So to avoid that, we load it as a image, because for scripts and images, it's allowed to be loaded from other domains than the original page. Okay, so now you can take a look at view opinions pages. Please go to that page after I've written my opinion. You will see a cookie alert that's saying that cookie is about to be stolen. For sure, a hacker would not include such an alert in his script. That's only for you and to show you that I have very clear intention. So we'll take a look at my log. Oh, it looks like I've stolen quite a lot of cookies. You can see differences in their form. This one is from Firefox, and this one, the other ones are from Chrome. So now I can exploit session. Basically, what I will do, I will configure a proxy in Firefox. My ZAP proxy is working on 1990 port. I will add a breakpoint in a proxy. Now I will try to access cookie. You will see that now the browser does not load the page automatically. It goes through proxy. You will see that my proxy, my JSession ID is different. I will change it to the one I've stolen, and we'll see how it ends up. Oh, we have the lucky victim. Who was that? Yeah, we've got you. Okay, so that was a pretty simple demo which showed how easily you can exploit Java application if not written properly. Let's take a look at code. What happened here? The code is very simple. We use a simple JSP page, we iterate over opinions, and we simply display them. I guess there is a very similar piece of code in your application as well. Who uses JSP? A lot of you. So, so now you are warned. The usage of simple display is very dangerous for your users. How can we avoid this kind of attack? We can use one more cookie configuration parameter, which is HTTP only. This parameter was introduced by Microsoft in their Internet Explorer version 6, as far as I remember. It was for the users to prevent XSS cross-site scripting attacks. So this flag instructs a browser not to expose cookie for JavaScript. So without that flag, we can JavaScript can access a cookie via document.cookie. With this flag, it's impossible, at least in the browsers which support this flag. It's not standard, but it's widely used. Every modern browser supports HTTP only. It was, yes?
Quick question about the HTTP only flag. Prevents the browser from accessing the cookie through JavaScript. I'm guessing it doesn't prevent the browser from sending the cookie when you perform a JSON call via REST API.
No, it's just when you send request automatically, it's okay. The problem is only with when you access document cookie from JavaScript. So it's not about sending requests, it's about accessing a cookie. So it's when you send a request from JavaScript, the cookie will be attached as with every regular request. So that was cross-site scripting along with broken session management, and that's why I hijacked one of your sessions. Another type of attack is session fixation. When a hacker opens a web page of a system in a browser, a new session is initialized, then a hacker stores somehow the session ID, then leaves the browser open, and the user comes and logs into the application. Unfortunately, the user uses the session initialized by the hacker. Then hacker can easily exploit the stored session ID to hijack the user's session. The solution to that problem is to change the session ID after successful login. In Java EE7, in serverless specification 3.1, we have change session ID method. In previous version, we can use the pair invalidate and get session true just to obtain a new session. So broken authentication and session management is quite a huge problem even in modern Java application. First of all, we should use random unpredictable session ID, at least 16 characters in length. Most application servers support that, so that's not a problem in the Java world. We should use secure transport and storage of session IDs. That's a problem. We should configure our web.xml appropriately to use secure and HTTP-only flags. We should consistently use HTTPS once the user is logged in. For example, we need to carefully serve static content because static content usually is served through HTTP, right? Not HTTPS, just to make it faster. In such cases, the server should be configured to serve static content from under different domain name. So not the same domain name as the application. Don't mix HTTP and HTTPS under the same domain cookie path. Why? Because once your cookie travels without any protection, it can be sniffed and then your session will be hijacked. Don't use too broad cookie paths because it can lead to usage of HTTP and then your cookie will be compromised. We should very carefully create and destroy session. First of all, new session ID should be assigned after login. That's a must to avoid session fixation attack. We should provide logout button for our users. And that sounds funny, but sometimes we forget that. We just implement new login for new user in the same session without any logout. Session timeouts. It's recommended for critical applications to set session timeouts to 2 or 5, maximum 5 minutes. For typical application, 15-30 minutes is enough. Why? We should keep our sessions short just to give the least possible time to hackers to hijack session, right? If our session would be very, very long, then hackers have more time to hijack it. One more thing. Why is it so easy to hijack a session? Remember the first exercise? My session was hijacked from different IPs, different browsers, and so on. That's not a typical behavior, right, of a user, to change a browser, to change an IP. When you open a browser, you interact through a browser, so it's the same user agent, the same browser all the time. Usually it's the same IP all the time. The IPs are, even if you are behind in art, the IPs are pretty static. So probably it's a good idea to keep some sort of original information, some selected headers from the original requests in our session, and then with every request check whether or not session user agent IP or any other headers match the original headers. If if they don't match, something's going on, and just in case for critical application, it's better to invalidate the session. It's important to base our authentication on standards and frameworks. Don't develop your own framework. Use what's available in Java EE. Make sure that your credentials are stored in a secure way. It's about passwords. Think about salted hashed passwords. You don't have explicit support for that in Java EE. You need to take care of that yourself to implement salted passwords. Who knows what salt is for password? So salt is an additional random string which is added to the original user password before hashing. Why to do that? To avoid brute force attacks with rainbow tables and some sort of lookup tables. Brute force attack with such tables is pretty fast. So once when not salted hashes are exposed and stolen, they might be easily hacked. So with salts, every password has that unique part, and lookup tables do not work very well with salted passwords. So it's not fast to decrypt and find the passwords. What about the support in Java EE? We have declarative security implemented using annotation or descriptors. But remember that declarative security does not force new session ID after login, does not associate any other headers with your session, just to check whether or not there was an attempt to hijack your session. So it's a good approach, but does not solve everything. There is a programmatic security supported from Java EE 7 with HTTP servlet request methods authenticate, login, logout. And this should be used for advanced flows and requirements. So my choice would be programmatic authentication with Java EE 7, just to do login, logout, and additional code. Those additional requirements include changing session ID after login and invalidating session on logout. And together with programmatic authentication, I would go for declarative authorization. So configuration in web.xml together with annotation, roles allowed, permit all, and deny all. The configuration details are based on application servers. Web.xml, of course, is a standard, but the configuration of realms and login modules depends on application server. Security constraint in web.xml, that's an example. Do you see any problem here? The problem here is pretty tricky. That we secure only two methods. Even though the other HTTP methods are not implemented, there is a trick in RFC that the default, when there is no head implementation, it falls back to get. So basically, and again, we can execute any get method through through head HTTP method. With head, we don't get response. So if our get methods don't have any side effects, that's fine, because we do not expose any data with head. But if it often happens that get methods have some side effects, so some modification into the database, and that's why such configuration is dangerous. And here we have connection to another point from the OWASP top 10, missing level function access control. In case of missing function level access control, we should remember to check always on server side to protect all web resources, to protect all services, including EJB, remote EJBs. We should remember to not expose UI navigation to unauthorized functions, and to implement all those things in such a way that it's easy to update and audit. So basically maintainable code. Okay, cross-site scripting. You've seen an example of cross-site scripting. Basically, cross-site scripting is when the user-supplied input is not properly escaped or verified before generating the output page. You've seen stored XSS, so our injected script was persisted on the server side. There is another type of XSS, it's reflected XSS, and more common when request data, when malicious script goes in URL in some parameter. Here you can see our script URL encoded. It could be included in a URL as well. And the example of reflected XSS would be that, for example, we have an application with a vulnerable search page, a query term displayed as is in JSP. Hacker's link would be like you see on the slide, hidden under some cute name, and the hacker could trick a victim to click that link, and it would end up in sending a cookie to the hacker. So what are the best practices to avoid cross-site scripting? Escape all untrusted data. With that example of mine you see before, the problem was JSP. Take a look at the code. There is another very similar code, which is facelet. So it looks similar, but under the hood, there is a completely different technology. With facelets, it would work fine because facelets escape parameters or attributes by default. So even though it looks the same, it works differently. JSP was default technology for Java server pages in version 1. It changed in version 2. In version 2, the default technology are facelets. So for those of you who use JSF, in version 2, it's more or less fine if you don't use JSP at all. So how many of you use JSF 1? Just a few hands. That's good. That's good. But we should remember there are a lot of people who use JSP still. So that's a problem. So if you use any other framework and it's based on JSP, you need to take care of that. You should usually display all your output through special tags. Like in JSF is H output text, you can use JSTL C out, and so on. So when you generate your web page, you should escape all untrusted data. There is another approach to validate input, and that's much more difficult because it's very hard to validate properly. We should base our validation on positive validation on whitelists, so allowed values instead of disallowed values, and validate as much as possible based on business rules. Okay, so cross-site request forgery. Another demo to show how cross-site request forgery works in practice. I will log into the application, then I will ask you to log into the application as well. Any non-empty username will work. And then I will provide you a malicious link. And you will see later on what happens. Basically, I will check my account balance, which should increase, definitely. So oops, I've forgotten that the proxy is turned on, so I'm disabling the proxy, and now the answer should be faster. There are waiting requests. Okay. So basically, this is a simple application which mimics like a bank account or something like this. It's very basic. We can transfer our money to anyone by name. So you can log in, transfer me some money, or if you don't want to transfer me any money, I will ask you to click a link. Wait a moment, I will find the link. This is a very unsuspicious page. Believe me. Oh, I've got the first transfers. Oh, this one is malicious. Because take a look at, yes, there are more coming. If you take a look at the source of the web page, you will see that it mimics the original application, but it does not show all the fields available to the user. Instead, it's based on hidden fields. So the source code for our attack is very simple. Take a look. It's basically the same form as you have on your original application, but all the fields are hidden and pre-filled with Patrycja and 6 as a target for the transfer of money, and with pre-filled with the amount 666. So basically, I've shown you how to send a request in the session of other users. We can trick other users to send a request, and they can even not notice it at all. So the problem here is that the browsers automatically send cookies when the requests go to domain name they have cookie for. So for attackers, it's enough to create malicious web pages and trick users to see that web pages. Users don't even need to click on those links. It's enough to have a web email client and enabled automated loading of images. I've shown you before that there is a trick in JavaScript that's we load completely different URL into image source.
How is that possible? Isn't the browser going to block that because it's not coming from the same domain?
Yes, that's the problem to avoid the same domain, the same origin policy, and that policy doesn't work for scripts. We can and images. So that's the exceptions, and that's why it works fine. So to avoid cross-site request forgery, we need to use unique tokens for our requests. And it's worth considering to use re-authentication before important operations. In Java EE, we have the support for out-of-the-box cross-site request forgery tokens. In JSF version 1, those tokens were a little bit too weak and predictable, so it was vulnerable. In JSF 2.1, we have strong tokens. Be careful with the last addition to JSF 2.2 of stateless views, which turn off the secure view state tokens, which basically serve as cross-site request forgery tokens. So without those tokens, it works much faster, and we don't need tokens for example, public anonymous pages. But on the other hand, we need them for all pages which are accessed by authenticated users. And one more thing, because we here focus usually on forms. In JSF, you can use protected views also for GET requests. It's configurable via protected views element in faces config. And then injections flows, and as I mentioned before, injection flows occur when application sends untrusted data to an interpreter, any kind of interpreter. Usually it's about SQL interpreter or compiler, but it can be also a JavaScript engine in browsers. That's about cross-site scripting, also type of injection. It might be JPQL or HQL in case of object relational mappings. It might be any query language for NoSQL database. It might be XPath, it might be JSON, it might be command shell. So all those tools are vulnerable when it comes to untrusted data and injections. A simple SQL injection. I think that SQL injection is one of the most common, most popular and well known. So I guess that all of you knows how to protect against SQL injection. We should basically use prepared statements, criteria APIs, and basically parameterized APIs instead of concatenating strings. Unfortunately, in some of those before mentioned technologies, it's not possible to use safe API. In that case, we, for example, XPath. So in that case, we need to be very careful about escaping. What are possible damages when it comes to SQL injections? For example, we can experience loss of confidentiality. Sensitive data can be exposed to a hacker. We can experience loss of integrity, like hacker can modify our database, modify data, modify structure of our database, and so on. So here it's worthwhile to mention that we need to apply the least privileges rule. So our database user we connect on from our web application should have the least possible privileges. So, for example, she shouldn't have rights to drop table, for sure. Also, with SQL injections, we can experience loss of availability of our service. Take a look at that benchmark. In such a way, when we benchmark hash function many times, it means that our database server is under heavy load, right? So probably users are not served at the right performance, or probably we can experience even some crash or something like that. SQL injection might be stored for the future, like hacker could create some trigger on update or insert, and that way it would be long-term vulnerability and access to our internal data. Here you have some interesting examples of injections. It's very important to validate data coming from all external systems, right? It might be strange to validate data coming from our barcode reader, right? But here you see the examples that barcode can be hacked as well. And that's funny, how to avoid speed tickets. So you've seen a very simple SQL injection, but there are other versions of SQL injection, like blind SQL injection. If you don't get any data, only 2 states of response, so you can test and exploit blind SQL injection. And there is timing SQL injection. If you don't get anything, you don't get anything from the server, or you always get the same response. But you can also trick the server to differentiate its behavior and then find out more. What about blind SQL injection? Blind SQL injection, we have a URL which returns only 2 states. The article is displayed or not. No article error is provided to user. When we append always true condition, we can check that the article is displayed. When we prepend always false condition, no article error is provided. So we don't get any specific data from that SQL injection. We only get 2 states, right? That the state is the article is fine, and the other states that there's no article. Based on that, we can basically do anything we want, because we can test any condition we want, right? So here we can find out the first digit of a PIN for a user. So this part of SQL represents our always true or always false condition from the previous slide. So if we get the article, it means that this condition is true. If we don't get it, instead we get the error, it means that it's false. And in such a way we can test all 10 digits, and we can find out which one is valid. Or we can use a binary search to speed up the process. So that's blind SQL injection, which can be used to find out many data in our database. And there is another form of SQL injection, timing SQL injection, where basically we always get the same response from the server. We know that the server executes our injected SQL, but we don't see any difference. So we can't find out what was the result of the execution. But take a look at this SQL if statement. Based on the condition, we execute the first branch or the second branch. So the first branch is benchmark, which takes very long time, and the second branch does nothing, which returns very fast. So basically we've reduced our timing SQL injection to blind SQL injection when we have two responses, but we differentiate the response based on time, not the data returned. So in the same way as before, we can find out any data in database, differentiating on the time of the responses. So it takes a lot of time to hack such a application, but still doable. So best practices. I guess that you all know that you should use a safe API. If a safe API is unavailable, you should carefully escape characters. You should consider usage of existing libraries. It's always important to do strong type checking and strong input validation, and introduce strong input validation rules. And security takeaway for you for the future. Nobody's perfect. We all make mistakes, but we all need to learn. We should use standard components and APIs. Java EE is a good choice, but it still needs to be applied wisely. And don't trust anyone. Validate all the data they are provided to your applications from any external sources. It's also important to include security into your daily routine and daily development process, just to have appropriate tools used, appropriate policies introduced, and appropriate attitudes in your team. So thank you. And if you have any questions, I will be available during the break so we can talk about that.